and then they're thrown away. So you will always end up with a clean build environment no matter what you do. This does, however, mean that your build will take a little bit longer in our system than if you were doing this on your local machine. We don't have any build caches, is essentially what I'm saying here. We've done this on purpose, mostly because we found over the course of years that, especially with Java projects, that if we don't do this, you end up with cache poisoning occasionally as somebody gets a bad object into their cache because they had a bad build, and then a different project comes in and does a build. So this is our way of basically making sure that whatever you have is going to be a clean environment. You'll also see that the build queue does build up. Got 4 in the queue right now. But we do tend to manage this fairly close, watch this fairly closely, so we keep it as low as we possibly can. We do build in a public cloud, and this means that as the project grows, we will be adding resources to this, so we should be keeping the queue fairly low. But we also have the ability to use all of the other components that ONAP has already developed, the heat templates, though we've yet to actually move those into the CI system here. So we do have an OpenStack on the back end of this. That's how we'll be able to do full end-to-end testing. You'll also notice that we've got tabs along here. This is for the top level projects. All of our projects, the jobs themselves are named after the project. We do this through a system called Jenkins Job Builder, which is a YAML definition of the jobs. It's basically YAML definition of all of the various build steps and the components that go into that. It's macro and templated, which means we can build a couple templates that everybody can use, and then it moves on. And then when you define your project, you only have to define a couple variables, and it actually builds out a whole bunch of jobs for you. For instance, I believe we have it currently set up so that you specify just a few templates, and you'll actually end up with like 4 or 5 jobs. And a couple of our other projects, you can literally add 3 lines to one file, and you'll end up with 5 jobs. It's that simple. And so this is basically what you'll see is the reds here are obviously failed. Yellow would be unstable. Blue is it's passing, and that actually indicates how it voted to Garrett as well. And what will happen is when Garrett comes back with a vote, you will end up with information on that vote. Actually, let's go into this one. Here, Jenkins, which is ONAP Job Builder, voted a +1. It also left a comment down here. Should have left it. No, that's my comment. It also leaves a comment with a link to logs. So we ship off the logs, we gzip them up. This makes it possible so that you don't have to go hit Jenkins itself. You'll get back this link in the Garrett email back to you. And then, yes. Oh. Just a moment. I think so. I don't know if I have it installed on this one. Meeting number 4? Okay. Alrighty. How do I minimize this? Where was I? Oh yes. Our logs. So as I said, we use up all the logs, and then we ship them over to the Nexus server actually, and then we host those out. This is done for two very specific reasons. One, Jenkins itself doesn't do gzipped log content, so the logs will actually come down slower if you're trying to view the entire log. Two, the fewer people that we actually have touching the Jenkins interface, the faster Jenkins runs. It sounds counterintuitive for such a well-used system, but Jenkins itself, the UI is single-threaded. And so the fewer people we have touching the UI, the better the system actually runs. So we prefer if you can go through the log link that you get. If you need to, for some reason, go to Jenkins, that's when you do it. But by default, please go and actually just view the logs directly here. They'll come down faster for you than if you were actually doing it in Jenkins. As I said, we have a sandbox system. It's the same URL, jenkins.onap.org. We just attach a sandbox. We don't have links directly to that, mostly because if you're needing the sandbox, you know about the sandbox. We will have documentation on how to use a sandbox, but you do need some rights to get to use the sandbox. What we allow you to do is you have full ability in the sandbox to push jobs yourself instead of going through the CI system, but you don't have the ability to push artifacts to Nexus or to vote into Garrett. And as I said, this one gets cleaned out every Saturday. It's an automatic job we have. It just comes through, purges all the jobs, purges all the logs. Artifacts. Since you are a Java project primarily, you're going to have snapshot artifacts as well as release artifacts. Our primary artifact store is Nexus. And what we have here is your staging repositories, your proxied repositories, and your release repositories for the artifacts themselves. We have jobs in place that will, or templates in place that will allow you to basically push to these things the proper way. There's just a couple of things you'll need to add to your POM files for your distribution management for server ID settings. Right now, it's all still saying it's ecomp. We'll be switching that over and pushing patches for that to switch it over to ONAP in the future. But that's basically what we have for that. One comment, I've noticed this with several of the projects currently in the system. We have a lot of them that have their own repositories currently defined in their POM files that are going external to our systems. Those actually need to be wiped out, and any repositories that we do not currently proxy, we need to know about so we can set up the proxies. We need this because it improves the speed of your builds because we now have the artifacts locally, but it also allows us to know exactly what artifacts people are using, which we'll need for when we're doing code scanning and object scanning later. Nexus 3, we have this system in place primarily because of Docker. Nexus 2 does not currently support Docker registries. Nexus 3 does. So all of the Docker objects that are currently in place live in this repository. You'll notice up here we've got 4 Docker setups that are listed. You've got docker.io, but it's actually part of a subsystem, which is Docker public. Docker public is, in the documentation you may have seen, nexus3.onap.org:10,001. That's Docker public. That is basically all of the Docker repository registries that we have in play. And it goes in order of docker.io, so upstream, docker.release, which is our release artifacts, docker.staging, which is staged artifacts, and then docker.snapshot, which are the snapshot artifacts. Unfortunately, Docker doesn't have the exact same concepts of the artifacts like Maven does, so we've just kind of played around with the registries. And each of these registries is 10,000. Docker.public is 10,001, release is 10,002, staging is 10,003, and the staging is 10,004, snapshot is 10,003. Those mostly matter when you're trying to deal with your registry artifacts. We do have templates around all of that. Finally, actually not finally, we do also have Sonar in play. Not all of the projects are pushing Sonar right now, but you do have the option of pushing Sonar It's just a matter of adding to your build to do a sonar build step in your Maven call, and it will automatically push to our sonar setup, and it'll start showing up here. So right now, most of the projects I believe are doing that on their release job, which is producing release style artifacts to a staging repository. But this, you could do it on your verifies or your merges, so you can do it more often than just once a day as well. And of course, everybody's already probably aware of Jira, so that is the issue tracking that we have right now. Jira is linked so that it will look for any Garretts that have the Jira ID in them, and it will link to them. Jenkins, Garrett itself is set up so that it can look into Jira, but and it will tell you that it suggests that you have a Jira issue ID in your commit message, but it's not enforcing that right now. We will actually turn on enforcement so that all commits into Garrett will actually require a Jira issue attached to them at one point. So that'll be turned on within the next couple of weeks. So you will not be able to push a change submission to Garrett unless you have an associated Jira issue, be it any type of issue. So it doesn't have to be a specific type. It doesn't have to be a task or story or anything like that. It's just any type of Jira issue. So at present, do I have questions? Yes. Casey, can you run some mics?
Thank you, Catherine Lefebvre, AT&T. I would like to ask you if there is possibility to extend the tool change and add some software like Fossology in order to make some check concerning the licensing.
Checks concerning licensing itself?
Yep.
There's been discussions internally about how we would do that. We don't currently have anything in place for doing license checking itself during the commit time. But it would be possible to add that as part of the Jenkins build steps, as long as we have a way of actually doing that. So yes.
Okay, so is it something we need to submit via the help desk, or?
We would right now, because this is actually, you're requesting a change to the environment as it currently stands right now. Yes, it would need to go into the help desk.
Okay, thank you. I hope I don't abuse. I would like to ask another question concerning Sonar. So maybe it has changed, but I was noticed that in fact the rules that we apply via Sonar, it's really based on the diff of different commits. Would it be possible to extend the rules in order to have a full scan in order to understand what is the quality test coverage and so on? So to change the rules, right?
So yes, we can change the rules. Right now, when we installed Sonar, all we did was we set it up with the default gate checks. So this is where the community needs to start stepping up and saying what they want Sonar to do. And as long as the consensus is reached, we will actually make those changes. That, of course, would end up going through the help desk because that is a modification. But if we have somebody that wants, people that come forward and say, this is what we need for the community for the various rules that we need checking, we can do that extension.
Okay, thank you.
Are there other questions?
Then I will ask another one. Right, back to Jenkins. You were mentioning that the principle will be that we have an automation deployment on an environment. I believe we are thinking about VEC host. I think it's not yet set up, but it's still the target to use that for automation testing, automation deployment.
The end-to-end testing?
Yeah.
Yes, it will be possible to do that. The tests just need to start coming in. I know that when eComp first came up, you didn't have the time to port the templates that are for Rackspace to VEX host, which is pretty much a vanilla OpenStack. Obviously, it is a production OpenStack, so it's not quite vanilla, but it's just a matter of taking the current templates and adding in jobs that actually execute on them.
Okay, so that's something we will still proceed.
Yes.
So at least we have the end-to-end suite
Yes.
also on the Linux Foundation.
This is something that you can completely do in our environment. We just don't currently have the test in place for it. We do this with one of our other projects. Open Daylight does heat templates as well, and currently they're in Rackspace as well. But if they were in VEX host, it would be working here too. So
okay, thanks a lot.
Hi, Michael, AT&T. Is it possible to attach personalized testing suites to the verified jobs?
Personalized as in your own?
Yes. The concern is that, let's say we have an external commit that's coming in and I want to test it. I want to, if possible, even add a +1 on internal testing for the component itself.
Okay, so you're asking a kind of a two-part question there. So part one is any jobs that are running in our Jenkins system have to exist in our Garrett system. So anything you want to do has to be there. So it has to go through the community review for that. If you're talking about a third-party CI system, especially one that has voting rights, we have a requirement that third-party CI systems have their logs available for up to 6 months in a publicly accessible location. We can provide the ability for those third-party CIs to push to our log storage, which is set up for 6 months, basically.
So it is possible that you'll provide a machine and deploy it.
No, so that's the thing. If you're talking about if you want to do additional testing, if it is part of our Jenkins suite, it will run on our systems. If you're talking about something that is a third-party CI, it needs to run on your system.
No, the idea is it will run on your CI and we'll have like an additional step for testing. Like Verify right now only runs JUnit. I would like actually to deploy something and to test it using integration testing that is hosted on our project.
So you're talking about chain tests?
Yeah.
We can do chain tests. We generally discourage chain tests on Verify because the verification should be a quick turnaround, should do a build and unit test only. Merge tests are the ones where you would want to do chain testing.
But merge test happens after it's already in the master. I won't be able to pull it out if there is an issue there.
What I would suggest you do is, I'm actually going to point you to one of our other communities, which is Open Daylight. Their integration project there does a lot of what you're actually asking about. They have additional Garrett commands that are left as commit messages or commit comments.
Like please release?
Which would basically, like the please release, which will actually end up triggering additional tests.
Okay, thank you.
You need a mic. I can't even hear you up here.
On his question is like an open hole community already has a capability to do that with the merged OLAP. We'll bring in those kind of capability and scripts into OLAP.
It'd be currently in the OpenO, Garrett, and Jenkins system.
Yes. Yeah, this afternoon in the integration session, we could discuss a little bit more, including we went to that location and also the web page you have. Similar as this one, but for OpenO community. Sure.
I just wanted to add a little bit to what Andy had said, which is it turns out that when your verified jobs take too long, it starts having a corrosive impact on the way that people in your community develop. So, and my rule of thumb is that if your verified job is taking more than about 20 minutes, people start doing bizarre and unnatural things because of this. So in an ideal world, we would all love to be able to test absolutely everything prior to merge. But in practice, the costs of that in terms of the behavior change that it engenders exceed the value.
Online commit, I don't know. If it's a one-line commit, I agree. But if it's a major feature that is just integrated, I prefer to test it before it reaches my master stream and it's already part of my application.
And that's why we suggest that you have keywords that are manually triggered.
That's a valid suggestion, and that works.
Yeah, absolutely. I mean, that works beautifully. We see this also with really deep performance testing in the FIDO community, where not every patch is at threat of causing major performance regressions. And so you don't run the 8-hour regression on every patch. But some patches you look at and just go, dude, this could go so sideways. And you do.
No, I agree. The suggestion by Andrew is valid and it can work.
Right. Gary's got a question over there. Somebody want to run a mic over?
Thanks. Hi, I'm Gary Wu from Huawei. So I was one of the tech leads for OpenO integration. The comment to add on to Ed's comment, definitely we like to see much faster verified job turnaround. And there are some cases in OpenO where the actual unit testing of any verified jobs themselves takes a lot shorter time to run than the actual wait for the spin up for the VM. And understand why we really want to have clean environments. So my question is, are there any plans to be able to spin up these test jobs using Docker, for example, as opposed to VMs?
So we already have Docker available in our environments. It is possible to bring up the environments on top of Docker instances if we had some that were defined. Essentially, what we do is we have instances that are defined with Docker. So ONAP's already currently doing this. OpenO was doing this. There at the end, we bring up a VM. The VMs come up pretty quickly. And then you'd be basically pulling a particular Docker instance. So if there was instances that way, yes. I will point out, however, because we do our instances as single-use instances, any shared cache would still kind of go away. However, if you were to put together a Docker instance and store it off in our Nexus that had a slightly pre-filled cache, right? So components that were already pretty much released. So that would actually help speed up your builds.
Yeah, I think I wanted to make the same comment. I don't think the delays right now come from the VM spin up. They really come from the cache issue, right? That's really where the time comes from.
I've seen a mix of both. Like sometimes a VM just takes actually minutes to spin up.
The larger the VM, the longer it will take. I will say that right now. We are in a public cloud, and they are a fairly busy cloud. So the larger the instance is, the longer it tends to take before it can get scheduled into their cloud, or as they need to shift load around. We saw this especially at the very end of OpenO. They requested a very large instance, which would sometimes take 30 minutes before it would finally get scheduled. So that's why when you're taking a look at our builds right now, you'll find that our default build instance size is the smallest that the cloud provider gives us. But we also have a few other builds that are happening on 2x2 systems, 4x4 systems, and 8x8 systems. So once we start stepping past that to like the 8x16 and then the 16x32 and stuff like that, that starts slowing down on their start on the spin-ups.
All right, very good. We're out of time for this session, so let's go ahead and move on to the use case and architecture close discussion. Mazen, did you want to lead this off?
Yeah. We'll just thank Andy. Great job.
And we're having camera issues this morning, folks, so we're going to ask the folks that come up to the podium to present to actually log into Zoom. Casey will be down to help you get that done, but we're going to have just a minor adjustment here as we switch off laptops.
So are there any representative from, we have two committees, and they're already working really hard at trying to come out with some proposals here. And my understanding, they're still working on the proposals. They're outside, okay? This wasn't as easy as some people think. It's easy to ask questions, and it's hard when you're part of trying to figure out the solution. So on the controller and the orchestrator, I believe they're coming in, and on the use cases, they're also coming in. We need to give them a few more minutes. So while waiting for them to come in, let me just say a few things. One is that we will try to finish the morning session before the parallel session, the one before the break, this session, maybe about 10 minutes early. And we'll all go out of the building and try to take a group picture. This is probably our only chance to take a group picture. Great weather. By the way, this is, if you're not from New Jersey, this is the weather we have all year round. So so consider moving to New Jersey, you know. That's one. Number two, I wanted to mention that we're actually starting today. Phil, if I may just go ahead while we're waiting for the team to come in. We're starting the voting for the vice chair position. This is the TSC voting for the vice chair. We have 4 candidates, and I don't see them all here, but I just want to recognize the candidates who've nominated themselves. I see Ala here. If you can please stand up so everyone knows who Ala is from Metaswitch, from Amdocs. The second candidate is Rajesh from Intel. Just want to make sure everyone recognizes Rajesh. Ling Li, I don't think she's here, but Ling Li from China Mobile. I think some of you met her yesterday. She presented a couple of times. And is Chris Donnelly here? He's just walking in. So Chris Donnelly is the 4th nominee for the vice chair. He just walked in. Chris, can you just raise your hand so people know who is the other nomination? Okay, so we have 4 nominations for the vice chair. The election starts today, and I think it finishes, Phil.
Officially, it will end on Friday, but if we can get all the TSC members to vote like by tomorrow's TSC meeting, that would be
Wonderful.
lovely to announce.
Great, great. So again, while the teams are coming in, it looks like has Shaker come in yet? Okay. Okay, all right, so good. The other thing I wanted to mention is that please don't forget the goal of today. The goal of today as a team is that we have to start taking the flows and the use cases and the functional architecture and drive projects. We have to drive proposed projects. We will review those tonight, and tomorrow morning we'll summarize what are the key projects we're going to go and write. So if you're part of any parallel session, which I hope every one of you will be involved in many parallel sessions, you've got to drive that home, is that, there will be debates about architecture, about technologies. Put those debates on the side. You've got to start driving into what are the projects. If the parallel sessions don't end up creating proposed projects, then the TSC, I'll have the TSC create those projects. So it's very, very important that you drive that home and try to put a lot of the debates. Good to have a debate for a few minutes, but move on to trying to put together a proposal. Okay, so we have two committees who are going to be. Yesterday, we said we had a subcommittee who are going to be talking a little about the controller versus the orchestrator, the role of those, and what are the technology around them. And 3-4 people, I saw them having that discussion after the drinks yesterday. By the way, how was the restaurant yesterday? Was that good? Yeah, Linux Foundation. Thank you very much for sponsoring. That was really good. Good food and good drinks and good company. And the next one was to go through the use cases end-to-end view so that each of the components understand their functional responsibility in these use cases. So who wants to start first? I'm also told whoever's going to be presenting have to log in on Zoom. Okay, so who's presenting? Can we look at the Chris? Who's on the controller orchestrator? Who's doing that? Jamil is there. Jamil and Chris, come over. Just like yesterday, what I'll do is that I'll give each one of them, each of these 2 areas, like a 5-minute overview of what they've come out with yesterday, and then we'll just open it up to questions. I really want to get more questions in so you can get some feedback. While waiting for them, tomorrow morning, 8 o'clock, we start. There's a TSC meeting for those who want to join us, the TSC meeting, and I believe it will be here. I believe that's the only room that we have that can support a large number of people. we'll probably have the agenda for the TSC meeting. Phil, will we be sending those out today? Today. Okay, they'll be on Wiki. And I'm guessing there will be buses for those who are attending the TSC meeting. There will be buses bringing guys here. Anyone has any questions while we're waiting for them? Just want to make sure that any areas that we need to address before we all leave this week. Okay. Everyone is good. That's good to hear.
Okay, so to kick us off, we were looking at the controllers and how they click in to the service orchestrator. And I want to start the discussion by talking about where we agree and where we disagree. First to call out all the team members, we talked with Jamil and his team from Orange, Chalker, Lingley, we had Matt Beal from Vodafone, and Ruben from AT&T, and Stephen from Ericsson. So it's been quite a team. We worked on it last night until they closed us down, and then again this morning. There are a lot of areas of agreement. First is the common use of the ONAP architecture framework. That we want to use all the components, as we go through the workflows, from the service orchestrator through either the AppC or VFC, and then bring up the VNFs, have them connect through DCAE, and then still be using ANAI and policy. So no difference there. Common view of the service orchestrator, the way it was implemented, MSO within eComp, OpenEComp, and GSO within OpenO are very similar, very analogous. We think that we want to keep that architecturally going forward. There'll be likely a blend of the code depending on how much we need to bring in to support the different components. Also, we want to follow a common set of VNF guidelines and VNF packaging. And we think that this would be a combined model from OpenO and from OpenEComp. And also that we want a common data model for the VNFs. Externally, we want to present the same view and same requirements to the outside world, regardless of whether flows are going through the AppC or the VFC path. And then a common mediation layer connecting to OpenStack, VMware, various cloud providers, et cetera. The area of disagreement, we had 4 operators and 4 different sets of requirements for how they would like to see the workflows going through AppC versus VFC. So we may have different paths for each of these different operators. Some people may want to do this at runtime, download one component or the other, and run 100% on AppC or 100% on VFC. Some providers want to make a differentiation based on Etsy Mano. If Etsy Mano is a requirement, then those flows would go through the VFC, and other flows might go through AppC. It could be the level of VNFM functionality or characteristics of the VNFs themselves, complex versus simple, et cetera. And then also there may be a need for differentiation within different network regions or different operating regions in the provider plant. So we are going to need some flexibility to meet all the different operator requirements. And Jamil and I have two different proposals to start the discussion. So the first one is that you have the two paths, and based on operator needs and choice, we can provide a modular framework, and we can steer the paths through either AppC or VFC based on the rules necessary from the different operators. They would both bring up their own set of VNFs. The VNFs would talk to DCAE, and then we would have the whole closed loop talking to policy, and then also registering in ANAI, and then being able to talk back to the different controllers depending on the different needs and the different path selection from the operators. And I'm going to let Jamil present next the second proposal, and then we can open it up for discussion. Yeah, well, I've got them on the flash drive, so it's going to take you just a minute to bring it up. Yeah.
Thank you. Yeah, it's not a really different approach or two options. It's merely an example of implementation of these two passes presented by Chris. Then we said that we will have this VF or VNFC, and when we discuss what is this VNFC, then say that's an NNF view and also a generic VNF manager. Then here the proposal is that if it's the VNFC, it's the NNF view, and as Chris said that we need to align with the NFV manual. Then the NFV manual is the main component at the entry of the architecture at the NFView. And then NFView, it's interfaced with the VNF manager and the Vim, the infrastructure. Then here we say that we can have the NFView connected to service orchestrator, same as Chris presented. And then the NFView can they can execute the Tosca recipe, and then he can it's connected directly to the infra controller for the to execute the cloud infrastructure. And also the NFView can use the AppC as a generic VNF manager, and also it's a VNF manager and an EM, what we understood from the app controller. In addition here, we added what was discussed yesterday also about this SDN agent, which also we agreed that it's an SDNU. Then we put it also under the service orchestrator, and then we have the possibility through this orchestrator to select the SDNC or a third-party SDN controller. Sure that this, as I put it here, it's the same for the what's presented by Chris, that we should be all the VNF guidelines should be aligned in the way we go from service orchestrator to app controller or SDN controller, or through the NFView. We should have the same VNFP guidelines. We should not have a guidelines for, if you can say, pass through service orchestrator and app controller, SDN controller, and another guidelines for the the second pass through the NFU and directly connected to the infrastructure of the app controller. Shows this architecture here. We can have also a possibility from the NFU to interconnect a specific VNF manager, but here we haven't put it in the overall architecture because it's something could be delivered by vendor, it could be outside the moment scope. But the NFU sure that can be connected to the app controller as a generic VNF manager, as well as a specific VNF manager outside the ONAPF architecture. Any questions?
Okay. Yeah.
I remember reading a paper on containers last year, I think ACM May timeframe. And I think one of the conclusions from that was you really try to keep configuration, simple data, well-supported languages. I guess my question is, do you think the root cause of the need for all of these things is a need to consolidate, get more standard, not domain-specific languages for integrating with these functions? Was there any discussion of what drives these different variations?
I think a lot of it is operator requirements and different ways of implementing in the network. Data modeling, I think, is definitely a part of this. And I think also operational practices. I know you're running AppC in your production environment, and China Mobile and other operators are running with NFBO. So part of this is we have a level of familiarity, a level of business processes already built up around one of these components or another. And then also operational requirements about ETSI-MANO compliance or other business reasons that dictate one path or another.
Hey Chris, can you hear me? This is Brian remotely.
Yes, Brian remotely.
So are those operating requirements different? Oh, sorry, it's a little echoing. Are those going to be documented on the wiki?
We'll post these on the wiki later. We just wrote them this morning, and so they're still pretty fresh, and we haven't had a chance to post them yet.
Okay, and I think to Jamil's point earlier, we are expecting that the exact same VNF package will work across these two different paths without distinct artifacts, et cetera, per the path. Is that correct?
You're cutting in and out. Let me see if I can paraphrase and make sure I got this. You're asking if the same VNF package can be used through both paths, and that's the intention. This is why this would drive the need for a common set of VNF guidelines. We have the Open eComp guidelines. We have the OpenO guidelines. We merge those together. Also, the packaging format with a tool like VNF SDK. So to the outside world, to the VNF vendors, we're asking for one set of requirements. And then we can process it in the ONAPF system and send it down a different path if necessary based on how the operators want to run the network.
So in your discussions, just want to make sure that we all get this, is that there's a clear understanding on the service orchestrator and the function of the service orchestrator. There's no debate why the service orchestrator exists in a stateless way, in a separate from the controller. There's no argument about the service orchestrator.
Correct.
The SO. Just want to make sure, because there was some discussions yesterday, we're going to put that. So really a lot of the discussions has been on the controller's framework itself. Do we agree that the northbound and the southbound APIs, doesn't matter what we do, controller's a black box, will be the same?
That's what we want to do. Short term, we may not be able to get there because we have two different code bases, and so we may need to bring in some code into the service orchestrator to
support. When you say short term, does that mean we're going to end up with two different packages as a result of that? Because we have not unified the southbound and the northbound API.
Southbound, we're talking about, we talked about yesterday, and depending on the naming, it was either infra C or mediation layer, but we're talking about a common way of talking to OpenStack or other cloud providers.
So we agree the northbound and southbound,
yeah.
we want to uniform those.
Yes.
We also, do we also agree, doesn't matter what the naming in here. I mean,
Yeah.
ultimately from an ONAP, we should be
Yeah.
calling this ONAP controller. I've got a lot of people yesterday coming to me and saying, this is just an ONAP controller. Okay, let's just not call these type of different names. Do we agree that we need different types of controllers based on what the function is? We need a controller for infrastructure controller, we need a service controller, we need a network controller. Did you guys agree that those functions need to exist?
Yes.
Okay. So really the major debate is what technology or what capability does which one of those?
Exactly. We have these modules called out in the charter, and there is a complementary functionality in AppC and VFC, just to call those out. That was the focus of the discussion. And we want to say, how do we support this? Because we do have different operator requirements. So
I'm a little concerned about the operator requirement, because the whole idea was to bring everyone on the same page. Did you guys discuss integrating AppC and the VFC?
We had some preliminary discussions. It didn't go too far. I think that would be a significant amount of work for both teams.
Okay, so I want to open this up. I think it's let's just have a discussion on just at least for a few minutes on where do you guys feel is the right approach? It's ultimately, I think, whatever our approach is today, whatever project we create, the community will drive it in one direction versus the other. So this is just a starting point, but I want to make sure that we are hearing everyone out.
Yeah. I actually had one question for you guys. I mean, you came up here with two proposals, right? And now when I look at it, the first one seemed much simpler and much more aligned with the, just the idea of having different plugin controllers with same source and outbound APIs than this one, which is kind of much more involved in more interfaces. So did you guys have a reason to come up with two proposals? I mean, what's the consensus? Is there consensus or?
We didn't entirely reach consensus. That's why we have the two proposals here. We have, the one view, which was to have, the AppC and the VFC at the same level, and then this proposal here is to have the NFVO and SDNO sitting in between. So the workflow, an ETSI Mano compliant workflow would go through NFVO and then over to AppC. So they're staggered.
Right, and that's that. I mean, this one is substantially, when you were talking about the amount of work involved of making this happen for release 1, this looks substantially more work than the other one.
Yes,
right.
I believe that's correct.
And I haven't heard a good reason why we should do more work.
Hi. Just it's not another option. It's an example of what Chris presented. We said that we need for example, VNFC. We say, okay, what's a VNFC? It's an NFVO and VNF manager. We say, okay, this is NFVO here, and let's start that VNF manager could be the AppC, and we'll see if we need another one. And it's a kind of, as Mazen said, a kind of integration. Then it's not another option. It's kind of implementation of what Chris presented. Chris presented high-level view that we have two passes, the VNFC and the AppC. And here's an example what could be the VNFC. Then it's according to what we agreed yesterday, that's an orchestrator and manager. And the orchestrator, which will be the NFVO, and the manager, here, for example, could be the app controller.
Sorry, but then I'm misunderstanding something. I mean, if but, you know, Chris, I don't know if you can pull your slide back up, but when I looked at Chris's slide, it was a very simple slide. It was basically, there are two parallel controllers. They have the same northbound APIs. They have the same southbound APIs. We don't need any mediation layer. We don't need any additional orchestrators. Very straightforward, very simple. One orchestrator, two controllers, same API, same flows. Now, in your case, there were additional orchestrators introduced. There were additional flows, which I don't see here. So it's not just an implementation. It is inherently different.
But here, what's the VFC?
Could I just address that point? That when you say it's very simple, same APIs, there's a contradiction there. Day one, so first of all, we need to pick a common API, and then we have to implement that. So it's not like it's just two controllers that happen to coexist. And then going forward, everything that's done in one, in ONAP, needs to be done in two. So every time you do a contribution to a controller function, you need to do two contributions, right? Because it's two different code bases that's merged. So from our perspective, I think from an ONAP perspective, it's much more consistent to integrate those functions into one mechanism, right?
Okay, so yesterday we had a very good analysis of the requirements that drive the three user stories or use cases that drive release 1. Now we've got two proposals, but I can't see how to decide between them because I can't see which technical requirements say I need to go with proposal A or proposal B because there aren't any requirements. So I think before you can take a decision on either of these two proposals, you need to say, here's the set of requirements that cause you to take option A versus option B, and then we can take a rational decision. There's a statement that says, oh, some operators need this, but I need to see the detail. You can't take a decision of this magnitude without saying, what is the driving use case?
So I think one of the things that we're hearing loud and clear is that there are different business requirements.
Write them down.
Well,
sorry.
Yeah, we'll. Sure. Absolutely. Absolutely. We'll take care of that.
Repeat it, please.
Repeat it, please.
My looking into those two slides is that they actually represent the same thing, just that the first one presented by Chris doesn't include the detailed flow, while the second one doesn't bring one example. I would say that there is no real architectural alternative here. The second one expresses in some more detailed way of what the first one has. So I would say that, in my opinion, we should really perhaps look on architecture alternatives, such as, for example, asked before by you, Martin, whether you consider it to merge VF controller and APSI, and then we can have pros and cons of each one of the options, again, applicable to the use cases that we have on the table. And then we can take a decision on what is the best architecture for the implementation. And that option of actually merging the APSI and VF controller, I don't see currently on the table.
Since this is open source, we may not get to one, at least not initially, because we've got, what I've been hearing is a significant differences of opinion across the community, that some people like the APSI approach and some people like the VFC approach. I think we have development teams that are committing to both of those approaches, at least in the short term. As operators start to make decisions and as developers start to make decisions, that's where I think that we will see alignment within the industry. But at this point, what we're seeing is still some divergence and opportunities for innovation.
So if you agree that the northbound interfaces on the controllers are consistent, they're the same. In essence, you can have a pluggable architecture where you have multiple implementations of that interface. You have a microservice bus, so there is no hierarchy implied. the hierarchy is entirely driven by business workflows. So it seems to me that you can leave as many of these controllers around as you want to. In fact, you can keep adding more as long as the interface is consistent. The workflows are the ones that are going to fire off those controllers in the right order.
Right. Agreed.
What's the big deal? I guess.
Good point. Okay. Making a good point. Okay. Next question.
Is it on? Okay. I'm thinking the two proposals, they have the same intent, which is to consolidate. Really what we're talking about here is AppC and the VNFC, because in your next proposal, there's not too much of a disagreement on how SDN controller should be managed. Over here, what I would suggest is to some other suggestion here to really identify their interfaces, because we should allow that flexibility in terms of what type of controller can be put in architecture. But I think a lot of the discussion here is really around the interfaces, which is not being articulated in either of the proposal. I think that's probably the confusion here. And in our afternoon session, if we can really start focus on the interfaces, then I think that will get us to specifically the interface of two, right? Because northbound and southbound has a lot of meanings. Here it's the northbound to the service orchestrator, southbound to, I'm guessing, to the Vim.
Yeah.
Exactly. Yes. So those two interfaces. Yeah.
Yeah, that was the discussion. That's where we want to get to, is the common interfaces. Sure.
Yeah, I guess, Chris, if you can split a page into two parts, on the left maybe your diagram and on the right Jamil's diagram. I can, if my memory is serving me correctly, Jamil had below the service orchestrator, you had the NFVO, correct? And the same NFVO that you're showing in your diagram goes to the AppC as a VNF manager. That's my understanding.
Yeah, that's the difference. There's a slightly different northbound.
So what we should do, I guess we are getting there, but there are some gaps there that Mazin said that we can address that. So if we put them side by side, people, they can see it, and you can see the difference in terms of the architectural functions. The NFVO, there's a long history behind NFVO and the manual. So we understand that. We have been there from day one, at least in my case. So Carissa's diagram in VFC, probably my suggestion is we can split it into NFVO if people they agree. And then the VNF manager part is already subsumed by AppC. Yeah. Okay. So yeah,
so
which
the difference here is that there would have to be an interface between AppC and VFC that doesn't exist today.
Yeah, that's correct. So we can split this into two parts, so we can. Yeah.
I would like to. I'm Dan from Huawei, and I want to ask some question for your confirm that try to confirm that for the southbound and the northbound, if it's the same. My assumption is that should be different, because my assumption is that for VFC there should be a special WinFM between the WinF and the VFC. So that means the VFC, the command that we send to the WinFM, and but APPC, FC, we direct communicate with the WinF. So one is the until now, according to my review of the code for FC, I think this currently the interface definitely is different, because this is for VFC is come from the SC, and another is self-defined. But yeah, that's something to clarify.
So we took out some of the detail from Lingley's presentation yesterday, but the way it was drawn up yesterday is the VFC box is what would be NFVO plus VNFM. And so in this, we're just showing this as a big box. It's called VFC.
Linux works only that VFC has a generic WinFM inside the VFC, but it's also capable to communicate with special WinFM. So
Correct.
this is a difference.
Correct.
Guy Metter from Cox Communications. So I think we have two things we're struggling with here. One is which components should ONAP deliver, and that's what I see here. Could you go back to the other diagram? Because I got a couple of questions about that one. The other is what functionality? How do we separate the functions, right? Regardless of which component delivers the function. And when it comes to that, as the gentleman over here was speaking about, if you have the interfaces defined to the functionality, who cares which components do it from a high-level concept perspective? I had a question about multiplicities because we have a use case from yesterday that talked about multiple domains. Is the intent here that there's a single NFVO or that you can have multiple NFVOs that the service orchestrator would interact with?
It's possible to do multiple.
Okay. I would think that it would be helpful to be explicit about that there are multiple NFVOs that could be interfaced with, that there are multiple pieces of functionality that the service orchestrator will select and communicate with, and having well-defined interfaces with that in a pluggable architecture where multiple components can be provided at that layer to interface with whatever. It's a common adapter pattern. And then the service orchestrator would select which is there. I think that pattern, if we were explicit about that pattern, it would help advance the conversation, because I really don't see a difference between the two. The first one is which specific components should ONAP deliver in release 1 versus this more generalized approach. So.
Yeah.
Sure. Yes. Yes. Right. And it goes to operator requirements, right? So, because if you have a legacy, it's hard to talk about NFV as being legacy, but if you have an environment where you already have an NFVO, does it interoperate with this or not? That's the question.
Just I would like to add a question concerning the use cases and the question answered this guy from IBM. Here what we are discussing, it's the what we can call option 1, option 2. It's should implement the same use case. Okay. Here discussion it's mainly how we can, what Mazen said yesterday, how we can integrate OpenO and ECOM. And here the component NFVO and SDNO coming from ECOM, OpenO. And at the end, we should, whatever we take option 1, option 2, or the NFVO or VFC or ZFC, we should answer the same requirement for the use case. It's not two different solutions. Same requirement should be handled by option 1 or option 2.
Thank you. Paul Bartoli from AT&T. Let me make an observation and then let's test it. I think on the slide that came prior to this, someone said earlier, you could add controllers, what's the big deal? I think one aspect of the big deal is, with 2, as that prior chart shows, and with any other one that I add, if a vendor or provider wants to make a contribution to one of those controllers, which happens to be the flavor that they're using, they have to introduce the same code change to the other controllers, or else you break the common northbound API. So I think that's a problem. That is a big deal. To me, that's a big deal because that says every person who's writing code, if their focus is one branch down that stack, they have to handle code for the other branches as well. That I think is a big deal. This picture seems to solve that problem in the sense that the SDN controller and the app controller
are the same, are each in their respective areas, one code base. So if I want to introduce a change to the SDN controller, I write one code change there. I don't have to write two as I would in the prior figure. I think that's the major architectural distinction between the two approaches. So I think I prefer this approach. I think it's cleaner. I think it's lower cost to build and get on the air and maintain going forward.
Yoav Kluger, Amdocs. So I think I agree, Paul, with your observation, and this is also the way I view it. I think, Chris, in your slide, you know, it looks very nice and clean, but actually when you look at the actual roles, so VFC is actually also an orchestrator. So if we agree on the roles of orchestrator, the roles of a controller, and that they are different, then VFC actually has both. And indeed, inside, it is divided to some orchestrator function and some controller function. So if we're saying that we will make the APIs the same, it means that the APIs will be much larger and consisting too much for AppC, because AppC is not an orchestrator, it's only a controller. And service orchestrator will have to send stuff or to use an API that is much more inclusive, just because it sometimes talks with VFC, which is really an orchestrator, and some other times it does more things, and then it goes only to a controller. So it's really, you know, you can make it the same, but it doesn't reflect the actual situation. There's going to be stuff that is going to be sent to AppC, which it doesn't need. There's going to be stuff that service controller knows how to do, but it is now going to delegate it to another orchestrator to do it because it happens to be in that path. So I really think that this illustrates the real situation much more. And as Allah said, I think the other alternative is to merge really, to make AppC one application controller for ONAP, such that if it is needed indeed to go to third-party VNF managers, it will do it, because it's a controller and those are also controllers, so it will know how to do it. All orchestration will be done by the service orchestrator. So
this is not the first time an open source community deals with this problem. And in order, I think, to streamline the discussion, what we have done in the past is you go back to the architecture principles. And that is, I think, where we need to spend the time, because really the question here is not could be dealt at a different level, rather than dealing with what is the advantage of this approach, that approach. And I really like Paul's comments about the fact that if we'll have two, then how are the interface working? So for me, the principle that needs to be set forward in the architecture concepts are, is this community, and each community is different on this one. Do we care about two implementation of the same? Don't we? Do we strictly adhere to, say, something that came from Etsy? And I know the AT&T answer to this. I'm just trying to show kind of, when you put those lines in the sand in the beginning, it's going to also save us time, because once everybody agrees to those principles, we are not going to get into, do I really want to have an SDN controller? No, we already agreed on the principles. I think it's going to save us time.
Hi, Avi.
Avi Chapnik Amdocs. I think one of the confusion I see in this diagram is the fact that the APSI is in the scope of a single VNF. All the APIs are always in a single VNF context where a VF controller or NFVO handles several VNF and the orchestration between them. Because of that, we cannot put them side by side and replace one with another. It's actually one on top of the other. And if at all, you can compare, like I think Jamil has shown, is APSI with a generic VNFM. I think one decision we should take whether APSI is the generic VNFM of ONAP going forward, or if we want to decide what is the alternative. This is how I see it.
Been raising his hand a lot, so you can go ahead number 5. So Steven, go first.
No, Shakir cannot. No, Shakir was part of the group.
Oh, okay.
Stephen Tuileries. A few things. We also, Paul, need to keep in mind there's an interface between the MSO and the NFVO. So I was assuming that would still be common. But I think we also, when it comes to the common interfaces, we need to think about, the point is valid. We can't sort of go forward in a way where the lowest common denominator is actually what stops us going forward. I think we need to work that one out. And that could also be a little bit, maybe there's primitives that you can receive, but you can't react upon because you haven't got that capability. That could actually be one option to think about there. I was going to say one more thing, but then we got into this definition of what's the orchestration versus controllers. As Mazen will know and others will know, I mean, it's the same thing. It was brought up. No, I'm just responding to the questions, not responding to you, Mazen. I'm sorry. But I think it's very hard to actually run with that definition there. But anyway, my final point, the one there is that if we also thought about this from a project point of view, if we were to actually put these into the same project, and if the work became too much, surely within that project, there will be actually a discussion about, can we do things more efficiently? So maybe one solution here could be that we can think about this. Yes, we continue the architectural debate, but let's constrain that within one project.
Okay, Vimal, and then Tucker, and we're done.
Yeah, so I'm looking at the Jamil's picture. I think there are opportunities to simplify it. I don't know why we need SDNO and NFVO. Do we really need two separate orchestrators, or can one of them do the job? Also, we need a very clear definition, what is done by SO and what is done by NFVO. I don't think that role is, or definition is very clear from the picture at least, because sometimes we go from SO to FC, or sometimes we go from NFVO to FC. What is the difference and how? So I think we need to have a very clear separation between, this is what we are doing at orchestration layer, this is what we are doing at the controller layer. As long as the functions are very clearly defined and roles are very clearly defined, then it becomes much easier to implement. I think we need to go to that level of detail next.
I can respond to that. The question is about some of the OpenO components. First of all, SDNO that Jamil put in, SDN agents in the architecture that was presented yesterday is responsible for setting up overlays and underlays across the WAN. So that's a little bit different from what's being done in SDNC. So that was the purpose on Jamil's slide. For NFVO, it's the resource-facing orchestrator. It's not the service orchestrator. So there is a difference in functionality between what MSO is doing or what SO is doing in ONAP versus what NFVO, now called VFC, would be doing. So the roles are clear. It actually does align architecturally. If you look at the eComp MSO versus the OpenO GSO, they're very similar. And so from a role perspective, it's not that bad to connect them together.
So the point that I wanted to make is that the two proposals are almost the same, right? Well, so yeah, you could disagree, but you gotta listen to me first. And then we'll disagree because I listen to you. So you could disagree with me, like I said, but we could have the technical discussion. And the reason that I say this is the following: VFC. If you look under the hood, VFC is NFVO, SDNO, and VNFM. What so happened is that what Jamil described is a specific example of VNFM, which happens to be the app control. I think the discussion that we need to have is, do we want to allow enough flexibility to introduce a VNF manager other than AppC to give the community enough flexibility, or do we want to bound everybody by one solution, right? I think as an open source community, I think we need to allow the flexibility. And I do respect all the comments that were made earlier, right? Including Paul's and everybody else, right? They're all valid. The issue that we have right now is we're trying to solve a problem integration issue. And the question is going to be, do we want to be flexible enough to allow a different flavor of the VNFM, or do we want to lock everybody into one implementation? My opinion would be, let's give everybody enough flexibility so they could choose, not too much, but enough flexibility so that they can choose their own VNFM if initially, and probably they would gravitate towards something common in the near future. But initially, it's very hard to take a hard line as to which one should be the default, the de facto default at this point in time.
Thank you very much. So in keeping with my tradition, I did want to respond briefly to something that Steve Terrell said, and then also somewhat in support of the gentleman who just spoke. There's a really deep desire to come together on one solution to a problem. It is the hallmark of healthy open source communities that they encourage people to work together. And so I think that's a natural and appropriate instinct. As long as we don't let that instinct cross over into forcing people to work together or not allowing mechanisms for people to agree to disagree effectively, those are the things that maintain the vitality of an open source community. So while I think it would be a very desirable outcome for the VFC, the VFC and the AppC folks to decide that they would like to produce a common project, I would counsel that we not force it. And I also see great merit in the suggestion that was made to leave flexibility, because one of the key breakdown points I've seen in other large communities of this sort is when you anoint one true way that cannot be competed with. And when that happens, often the problems that can't be solved by that one true way, or that one true way is uninterested in solving, become wholly unaddressable to the detriment of the overall community.
All right. Thank you, guys.
Are you on? There you go. Yep. There wasn't a discussion about whether it's
while they're putting this on, my point is that let's drive it from the use case. We will create a project independent of what the view is, option A or option B. I want to also remind you that we will stick to the date of the release, which is the fourth quarter this year. And that may push us into one option versus another or two options. We have to allow the flexibilities, but we should focus on the APIs and trying to at least interlock on the APIs. I've mentioned to a bunch at the TSC meeting yesterday that we're not going to let anybody play with the APIs. Change of an API would require change management from the TSC. TSC has to approve change of APIs. And as long as we fix those APIs, we do need to provide some flexibility for other communities to innovate. But for today, we will not resolve all this. We will have the parallel sessions. We'll create a project on the controller. We'll create a project on the orchestrator. And we will let that community sort of try to drive a lot of that forward. But the APIs is what we should focus more on, and the use cases that are driving those APIs. Are you guys ready or not? I'm singing and dancing in here. By the way, while I'm waiting for them, just something for fun. There were option A and option B, and Shaka would claim they're both similar. But could you raise your hand? There are different implementation details. Who would go for option A? Just option A, raise your hand. Chris Donnelly sort of presented option A, two parallel paths. Option A, which was AppC and the VNFC, sort of use both codes in parallel, APIs, common, both northbound, southbound. Option A. Who would go for option A? Okay. Who would go for option B? More people for option B. Interesting. Again, folks, open source doesn't work like that. I was just interested for everyone to get that kind of feedback. All right. We're ready for you.
Can you hear me? Yeah. Okay, so we did not have a lot of time since last night. So so yeah, we definitely used the party last night to also do this, but then a bit more. So we did the VCPE use case but the intent is really to show the flow. So it doesn't really matter which use case, just so happen to be easier for us. So let's assume that this is the service. And again, we showed yesterday the service, and it was a bit more involved than this. But just for the sake of this flow overview, let's assume that this is the service. There's a VBNG, which is chained to a VH gateway and then to a vRouter. Let's assume that this is what we need to produce. So we actually have three general steps in anything that we do. We have the onboarding, then we have the design step, and then we have the runtime. So this is very generally, and these are the things that we do in each of these steps. And let's see how. So a little bit in more detail. I should say, by the way, I didn't mention it before. We had people from AT&T, from Orange, and from IBM on the team that work together. So, so step one, we said onboarding, and here we are actually. So there is a person sitting on the VNF SDK, I have to admit, I don't know the VNF SDK very well, but but presumably it is a system that you can log in, you can enter your image, your heat files if it happens to be heat files, any other models that you have, and eventually do all the necessary steps to onboard the VNF. This is, by the way, a per VNF step. So given we have 3 VNFs here, then you would do the onboarding 3 times for each VNF. And it could be, by the way, that these VNFs come from 3 different vendors, and then it would be done, these onboarding sessions will be done separately in different times. But now they're all onboarded. So now the next thing that happens is service design. We could separate it to design and distribution, but it was easier to do it in the same slide. But the idea is that now designer is sitting on the service design platform, designing their service, and also on the policy creation to create the policy on the analytics application, design studio to design all kinds of analytics functions, and actually control loop is designed exactly in this phase, and we have specific slides that show the more details about the control loop. But the idea is you do all the design, and when you're done with everything, you put it in the catalog, and now and you went through certification if needed, and now when it's all done and everybody is happy with the result, you can hit a button. But actually, what it does is SDC issues an event to DMAP with a link to the artifact. And the ONAP modules receive this event, and they know where they need to go and get their artifacts from the catalogs. And so now they're doing it. Go on. Now they have the artifacts in their respective memories for this particular service. Nothing else has happened. In particular, no service has been created because no request for a service has been received. It's only the artifacts that these modules will need when an order comes in, that they have it, but nothing else. Next step, and this is actually, this step is done whenever things change, so it's not necessarily a one-time activity. The next step is a customer order, and I just put it here as just so that we know that since this is a customer-facing service, an order will have to come in order for anything to happen with this service. This is external to ONAP, so we're not showing it here, but this step is number 3 in order for number 4 to happen. And then when the order comes in, so this is actually step 0 here, a request to instantiate VCPE comes into Service Orchestrator. What we see here is that each one of the modules have artifacts from SDC. That's the artifact that we saw before, that they were flying into those modules. So they have it. And now as the request comes in, so SO looks for the BPEL recipe that will serve, will run this request. and it fetches all the artifacts that were received from SDC before in order to be able to instantiate this service. This is an optional, today in ONAP it does not exist, maybe it will come later. But if homing or placement decision has to be taken, this is the time to take it, because everything else after that will happen on a particular OpenStack site. So actually, there may be multiple sites, multiple places, multiple regions. You have to know where you're going to instantiate. So you take this decision, and then and there is activity with ANAI. You create a customer object if it doesn't exist, and then there is a step that is to do resource assignment. Now, in ONAP today, it is mostly empty because it needs so different operators might have different ways for how they do the assignment. For instance, if it's an IP assignment, maybe this service requires a few IP addresses. So there is some system at the operator that, yeah. 1 minute. Ooh. 1 minute. Okay, so we'll rush through it. So SDNC does all these assignments, and it updates the inventory, then it goes back to SO. SO goes to OpenStack and requests to instantiate, sending it the heat template that it got from SDC, plus the environment variables, plus information that it got from SDNC as far as the assignments, enough for heat actually to instantiate, and also to do the chaining. So this will be created, and then it goes back. ANI is updated, and now we're done with instantiation and chaining. Service is not yet up and running because now we have a few more steps to do configuration. So we go to controller. In this case, we didn't say exactly which controller because we didn't want to get into this debate. But it goes to a controller, and if it's APC, it's APC. And then the configuration is done. Again, ANAI is updated. And now we're not quite ready because we need to also monitor. We have, so DCAE has to be notified, and then it fetches information from ANAI on this service, knows where it is, on which VMs, where it needs to monitor and what also, again, because it had received it from SDC before, so it knows what it needs to do for this service, and it goes and does it. In the case that there is a need for local DCE, then it can be instantiated also. And it is monitored. And then when all this is done, then we can go back to, I'm not showing it, to the requester and say, yeah, it's done. Service has been created, and it's running. So this is the instantiation flow, and we have 2 slides on control loop flow if we want to cover this as well, if you would like. It's here.
So you've explained how you instantiate the VNS. So we start, so basically you have service and you have service assurance, right? So I'm going to describe a little bit about service assurance. And the job of service assurance is to deploy a control loop, essentially a closed loop or an open loop. And the job of the control loop is to repair a fault. The fault could be a performance problem, or it could be an actual fault, right? So how do you basically describe a control loop? how do you deploy the control loop, how do you activate the control loop, and how do you monitor and watch the control loop. That's essentially what we're doing. And so in Yov's picture, you saw one service which has 3 VNFs, right? The BNG, home gateway, and vRouter. So for each of those VNFs, we want to attach a control loop circuit, if you like, or a control loop recipe, right? And I'm going to describe generically how do you basically build that control loop to attach to that particular VNF. And if that VNF is at fault, that control loop will kickstart, and it will try and repair that fault, maybe to restart that VM or to rebuild or to migrate, right? So we start at ASDC. In ASDC, and it's sort of control loops are template driven. So we have, at least in ecom, we have created certain control loop templates that are prefabricated. Essentially, there are fault management templates, there are performance management templates. And for fault management templates, we are basically taking SNMP traps, and based on the SNMP trap, the fault that actually happens, we want to detect what that particular fault is, and we want to take some action based on that fault. So there is a template that has been created and ingested in the ASDC catalog. There's a control loop designer / cockpit. The control loop designer basically retrieves that template from the ASDC catalog, configures that template for that particular BNG VNF, and says, okay, what are the components of the control loop that I need? This is where you do it in the designer. You basically need a microservice, you need a collector, you need some configuration and operational policies to be described. These are all activities of the control loop designer's job. So we provide them a simple way for you to be able to describe how you should do that in that template. So once that template is configured, what we do is basically we send it back to ASDC as part of the designer, and ASDC then distributes it out to all the recipient components, DCAE, policy. So this is what happens in step 9. I'm sort of skipping through some steps, but essentially a template is already there. In step 3, 4, and 5, we retrieve the template, we configure the template, and then in step 7 and step 9, I actually basically send or distribute the template. So at this point, the template has been configured, but it's not activated yet. It's waiting in DCAE, ready to be activated. Now what happens is, when the service comes on, the service orchestrator starts the service, the BBNG. It also sends a trigger to DCAE saying, check if there is a control loop associated with this service. So is there a service assurance loop? And if they check inside DCA inventory, oh, there is a service control loop, then basically DCA controller's job is to activate all the components that are described in the control loop, the microservices that are actually doing the fault detection, the policies that will be activated. So that's basically the design time part. We configure the template, we send it off to the recipient. At runtime, what happens is, when a fault actually comes in, the fault basically comes in, I'm giving an example of a fault detector. It comes in from the BNG to a trap collector. The trap collector basically collects raw traps. You have to then normalize a certain set of traps to some JSON event. So there's an event normalizer that usually typically takes place. That event normalizer then basically sends those events to a microservice. And this microservice, the fault management microservice's job, is to look out for the particular set of strings that are inside, that are embedded in the SNMP trap, right? And then basically, once it's detected a particular signature, it sends that event to policy, and policy is basically ready and waiting, and it knows, okay, for this signature, this is the associated action that I have to take. In this particular case, we might be able to restart, let's say, the BNG if it fails, right? So policy then makes a decision saying, okay, I have to restart. Which controller do I talk to? I may talk to AppC, I may talk to SDNC, I may even talk to a service orchestrator. And it sends an actionable event to a controller. The controller then talks to a particular OpenStack controller and actually makes the restart happen. So this is basically the closed loop. A fault happens, a signature gets detected, policy takes action, a policy suggests an action, AppC then takes action, and then the loop is closed. And in any fault, there is always an onset and a clear. So when the first fault happens, there is an onset event, and when the fault is cleared, there's a clear trap.
Okay,
And that's how you
sorry, I
reset.
have to stop you there. Okay, anything else we have to present? Okay, you have 1 minute and I'll stop you after 1 minute.
You don't have it here?
1 minute and it started already.
You just want to hook it up. Doesn't matter, just hook it up.
Can I just hook it up?
Start talking about it while
Okay,
you
so
bring it
yeah, so the final step in life cycle is to do change. So if you want to, for example, upgrade the software that's running on one of these VNFs, you have to use this change management process. Now, just like the other steps, the change management process is also split into sort of the design time phase and the runtime phase. So in the design time phase, what you're really doing is you're taking advantage of the building blocks that the different components of ONAP have available. So what are the APIs that the controllers expose? What are the APIs that the orchestrator expose? And for that specific VNF or VNFC, you're basically saying, what are the building blocks I want to use? So you essentially can compose these workflows at design time for as part of change management and say, for this VNF, these are the steps that we want to execute. You do this design, and then you sort of keep it and store it in the catalog. And then when you want to actually do the change, you may want to do it in two ways. You may want to trigger it right away. You may want to schedule sort of change for a large set of instances that are running. Now, when you're doing this, you want to make sure that you don't sort of conflict with other changes that are going on. You want to probably schedule it in such a way that it's all sequential, or, take dependencies into account and so on. So the way we see it is, you come in and you trigger this change. It sort of goes through some sort of a change management schedule optimizer. The schedule optimizer will take in information about dependencies from ANAI, policies that users may have set, information about other activities that are going on. It then comes up with an optimal schedule. You may then want to interact with some sort of an OSS or a BSS system that then operators can come in and say, yes, we approve this schedule, and then that schedule is what sort of gets populated. And then at runtime, you're going to basically start execution based on the schedule that was generated. Now, here's an example of lots of steps, but in an abstract, what's actually happening as part of change management is really that the sequence of steps that you created as part of the design get executed. That may involve tests that you're doing before and after. So you do a test before to capture the state, you do the change, and then you do test after to figure out if everything is okay.
Sorry, I have to stop you. Okay, thank you guys. Really appreciate it. I think you guys did a good job. Put this on the wiki if you don't mind, so people can have a chance to look at this. We're gonna go and get a picture, a group picture outside the building. Before you go, I just want to give you some instructions of what's going to happen next. We have a break for 15 minutes. Because we're going to take a group picture, we'll start, Phil, 10 minutes late. We'll start at 5 to 11. After the group picture, we'll try to please go to the para rooms. We'll start as soon as possible after the para room, after the group picture. There's stuff outside here. There are 4 parallel sessions. Okay. There's the next ones. One is on MSO, modeling, DCAE, and use case VNFs. Okay. What I'm looking for, so the MSO is in this auditorium. The modeling is in the multiplex room where we had the tutorial yesterday. DCAE this is all information on the wiki. Okay, it's in room A45A02. And the use case VNFs is on B14C01. So here's what I'm looking for right now. There's a template that we've put on the wiki for each parallel session for a mediator to fill out. Okay. Basically, we're trying to drive what are the projects we need to do based on what you've heard in the use cases. What are the projects that we need to go and create? What I'm looking for right now is a mediator for each of these sessions. A mediator is a person who is going to fill out the form and just get that discussion going. not a technical leader, is just to get the discussion going, fill out the form, and come in later today and give the readout of that template. So for the MSO, who would like to be the mediator for that template? Who would like to be the MSO mediator? Okay. All right. I hope we will. Okay. We've got to have a mediator. All right. I'll wait until. Can I have an AT&T person make sure that for those people who don't know where the other rooms are, let's just make sure so the AT&T folks can at least show you where they are. Jack Murray is there who can help if anybody wants directions. Jen Yates is there and Rich. Just reach out to them and they'll tell you where the rooms are, and Tony as well. Okay, shall we all go out for the picture? Okay.
Mazen, one quick more organizational thing. For the guys which keep the notes for the breakout session, you will need a Linux Foundation login. So if you don't have a Linux Foundation login and you're going to keep notes on the wiki, now might be a good time to get one.
Hello, everyone on the bridge. Just to let you know, we will begin again shortly.
I got one mic.
Maybe we should start. I think Bill was going to cover the issues, but time's running, so maybe we should start. The idea that we'll run with this, and I think we're starting with the Casey Joyce. Oh. Okay. Hello, that's better. So the objective of this session, or this set of sessions, I think, is to go through. We've got the two use cases, and if we get when we get this up on the screen, so I'm going to try to actually sort of moderate this towards the objective. And while we're doing this, Chris is going to try to capture down the comments in the discussion, and we'll go through and capture the questions. So there's two parts to this in a way. One part is based upon what we're seeing a little bit of the use cases and what we know of the functionality, try to capture down what we think might be the needs for this and the dependencies for that. So we'll take that discussion for, say, some 15, 20 minutes. And then we need to turn this around a little bit into the discussion. Okay, based upon what we know of this, which may or may not be complete, what's the projects that we actually start to need? So the end of the objective is to have something where we can later go and collect all this and saying, here's the set of projects that we think we need, so we can actually go ahead and start defining that and have a place where people could actually really do some real work, not just some slides there. Do we have this up or? Okay. Okay. And the results of this will be directly on the wiki, and I also believe an IRC chat is open, so I'll to capture questions as well from the people that may not be in the room. I'll actually try to bring that up a little bit. So, and the first one, if I got it correctly, actually was the MSO, right? Yes. So if we start with the MSO, and then we started, there were two use cases. One was, well, three use cases, but let's focus on the vCPE and also the virtual VoLTE, which sort of comes down to the IMS and the packet core there. What would be some level of needs that you think we might actually need to do that might be on top of what we have today? Or if it's not on top of, it's just something that we need to be able to, let's say, capture kind of as a requirement, but I think we should call them needs. Does anyone have something where they might like to start? Yes, please. Sorry, Mazen, we started without you.
So this is KJ from AT&T. I think one of the things that we would need to do to at least capture some of the use cases, for example, the vCPE, is have some way for the service orchestrator to decide where there is enough capacity and where these things are actually going to be placed. So a homing function would probably need to be there, at least for the use cases where we are going to deploy this in, the service across lots of different areas. For example, the vCPE.
Excellent. I think that's a great thing to put down when we start this, when we get it going there. Are there any dependencies? While we continue that, are there any dependencies for that type of functionality that we might have on other components? Can we just continue with that, just that thread before?
Yeah, I mean, so I can speak to how we do this sort of thing in the e-com side of things at AT&T, and maybe that can help shed some light into what we need within ONAP for this to happen, right? So at the very least, you need a level of inventory and capacity data to exist within an AI.
Okay, so there's a dependency in the ANA to capture the capacity.
Right.
Let's make sure we remember this while Chris is starting up. We'll have to see it on the screen in a minute.
The second aspect is that these services are going to have policies that dictate constraints on where these things can be placed, right? So in the case of a VCPE, for instance, you perhaps have a latency constraint to the actual user of that service. And so the policy, the design framework, as well as the policy part, needs to store what those constraints are for that particular service. And then finally, when an actual user becomes onboarded onto it, right, there has to be a runtime component that goes and pulls these, both of these bits of information, the real-time information about where capacity exists, and then the policy information about what the constraints are, and then actually figures out, where to do the binding, right?
Very good. I think this is enough level of information to capture this for now. Thank you for that. Vimal had his hand up. He was going to be next there. The quick summary, and can we help, Casey, can we help get the laptop here up on the screen?
So just a follow-up comment. The Vim infrastructure also has a placement, right? Now scheduler has its own. So how does this will be impacted by that? So how do you handle that?
So I think there's two levels of scheduling and placement, right? So the stuff that happens within the cloud infrastructure, the underlying cloud infrastructure, for example, VMware or OpenStack, they have their own schedulers. And when we move to other third-party clouds like Azure or AWS, they have their own internal schedulers as well. But there has to be a ONAP level scheduler in some sense that figures out which of these clouds you're actually going to go to, right? So it's really a two-level thing. Part of it will be handled in the VID and in the infrastructure provider, but part of it has to be handled from a using the service constraints, right? And picking even the right sites that would have those capabilities that the service needs.
Can I ask this topic that we cap here, and then Chris asked for this, because maybe we need to also, it's better to go for breadth than actually bring up the more, so we get some rough thing. So it's basically was to have a homing function